Hello friends, in today's question, for the figure, both pulleys are massless and frictionless. A force F of any possible magnitude is applied in the horizontal direction. There is no friction between M and the ground. Mu1 and mu2 are the coefficient of friction as shown between the blocks. Column 1 give the different relation between mu1 and mu2, and column 2 is regarding the motion of M, match the columns. So this is a basic figure. We have a mass capital M and two blocks of same mass small m. The coefficient of friction between them is given as mu1 and mu2, and there is no friction between the capital M and the surface. So this is the column. We have to match them. Now here important thing is that it's said that the force F of any possible magnitude is applied. So let us first of all find out all the possible friction forces which will be acting between these blocks. Okay. So let's draw it here. So this is mass capital M, and we have this as small m, as well as this also small m. With the help of a string, it is connected. So there will be a tension T here. Force F is being applied in this direction, and there will be tension T here also, as it is a single string, and they will be connected like this. So this mass M will try to move in this direction, and this will try to move towards right. So because of that, there will be a friction between M and capital M in this direction. Let us call this FR1, and here it will be FR2, and because of that there will be an opposite friction here, FR1, as well as here, which will be FR2. So these are all the forces which is acting, and it is given that here the coefficient is mu1 and here it is given as mu2. And force is being applied towards right side. So in the first case, it is given that when there is no friction, coefficient of friction mu1 and mu2 is 0. You can see case 1. Mu1 and mu2 both are 0. So if mu1 and mu2 both are 0, so we can clearly see that both FR1 and FR2 will be 0. So if both FR1 and FR2 is 0, you can see that there will be no force acting on block M in the horizontal direction. You can see there is no force on capital M in horizontal direction. So if there is no force, M is not going to accelerate. M does not accelerate. So case 1, the option C is correct one. Okay. So you can say 1 is matched with option number C. So this was our case 1. Now we go for the case 2. In case 2, it says that both are equal but not equal to 0. Mu1 is equal to mu2 but not equal to 0. If mu1 and mu2 are equal, from here we can say that fr1 will be equal to fr2. Therefore, the net force, let us say this is our block M. We have fr1 towards left and fr2 towards right, and if both the forces are equal, there is no net force on block M. Okay. You can say no net force on the block capital M in horizontal direction. So as there is no net force, so this means M does not accelerate. So it does not accelerate. So for option number 2, C is the once again correct option. Now we come to case 3. Case 3 states that mu1 is greater than mu2. Mu1 is greater than mu2. So if mu1 is greater than mu2, then from here we can say that the frictional force Fr1 will be greater than Fr2. Frictional force is greater than Fr1 and Fr2. But in this case, there is one more condition which is given, which states that applied force is of any magnitude. So it basically means that if F, that is applied force, overcome the frictional forces, Fr1 as well as Fr2, then M accelerates. So from this we can say that if F is greater than Fr1, Fr2, then M accelerates, and if applied force is less than Fr1 and Fr2, M does not accelerate. So even though the value of the friction Fr1 and Fr2 is different, and from here we can also say that there is net force on capital M. Okay. So even though there is net force on capital block M, under these two conditions the M can accelerate and M does not accelerate. Okay. So from here there are two options for us, that for case 3 there are two options. One states that it accelerates, which is option number B, and other states it does not accelerate, which is option number D. Now we come to case number 4, which once again states that mu1 is less than mu2, and from here we can say that Fr1 is less than Fr2, and say that there is net force on M. But once again, same condition, but if applied force is greater than Fr1, Fr2, you can say M accelerates, and if F is less than Fr1 and Fr2, under this condition M does not accelerate. So you can say that, yeah, there is, so for this fourth we have two options, A as well as D. Okay. And option A states that accelerates towards right. From here you can see accelerates right, and from option B it is accelerates left. So the consolidated option is, for our first case, option number C is there. For second case we have option number C. Option number C is there. For third case we have two options, either it will be B or it will be D, and for fourth it will be either A or it will be once again D. So this is our correct options. Thank you.